Hello, this is my solution to discussion number 3. Push that away. So we have, I should probably write here where the two roots are. That's I. So what we have here is we're given this equation, this Quadrature equation. I'm not sure how to pronounce it. But we have this equation, we have A, B, C, D. We are also given, I found the auxiliary equation to go with it. And what we're trying to do is basically figure out what our A, B, C, D is equal to, and we plug those values back into our normal equation. And in the way we are given our roots, we just have to work backwards. So for what I did, first, I'll put this part up here. We have m equals 3 and also equals negative imaginary I. Well, let's look at 3 first. Obviously, 3 had to come from, let's see, 3 had to come from m minus 3, because if you think about it, 3 minus 3 equals 0, and that would be a solution to our set, I guess. And then negative I would have to come from something with a square, so like m squared plus something. So what it should be, and what I found out, is that m squared plus 1. So if we solve these, just to check, we get m equals 3, because m minus 3 equals 0, bring the 3 to the other side. Then m squared plus 1 equals 0. We got m squared equals negative 1. Square the other, take a square root of the other side, get negative plus or minus the square root of negative 1. Then m equals plus or minus I, because square root of negative 1 equals I. We have a plus and minus, that's one of our solutions. So if we go down to over here and we say, all right, so we know, so this this equation up here pretty much confirms what our basically says, I'm sorry, this form up here is the way we can get to our answers for A, B, C, and D. So if we FOIL this, we get m cubed minus, well, plus m minus 3m squared minus 3. So then we can put this in a better form. I'm just going to erase it and put it up here. M cubed minus 3m squared plus m minus 3. So this is our equation. So now I'm going to make a little chart here in a different color. And what we're going to do is figure out our A, B, C, and D values. I like to do this. So A is very easy. We have A x cubed, actually no, not there, right here. A m cubed, right here we have an m cubed. So obviously A is going to equal to 1, because right here we have a 1 in front of the m cubed. And so that's A. I'm bad at explaining stuff. B is going to equal, if we go over here, so this part of your equation, equals the coefficient over here. So we have a negative 3, which is going to be on the other side equal sign. Let me put this. We're going to have a B minus 3A equals our negative 3 right here. And then we can plug in our value for A and get B minus 3 equals negative 3. Bring the 3 to the other side, that's just going to make a 0. So B equals 0. Our C value, I don't know how to write that, just going to reset. We get 2A minus B plus C, because our value right here, and then equals 1, because there's a 1 over here, higher M. And then if we plug in our values from our other A and B values, we get 2, 1, plus plus minus 0 plus c equals 1. So we get 2 plus c equals 1. And then c equals 1 minus 2, which is a negative 1. So then that's c, and then d, if we go over here, this lines up with this almost, we have d equals negative 3 basically. So then we have our values, now we can just plug them back in. So our final answer is going to be right down here, so you can see it. A, so x cubed y triple prime plus, well, we have a 0 here, that's just going to cancel, plus 0. Then we have a negative 1 for c, so x cubed y triple prime minus xy prime plus, well, actually not plus, minus, because we have a negative 3 for our d. Negative 3y is going to equal 0. Alright, so then this is our solution to our problem, and that's my answer.